Hello everyone, this is the problem of the week solution video for the problem sum squared digits. The problem description goes as follows. The sum squared digits function, SSD, which takes in b and n, of a positive integer n in base b is defined by representing n in base b, as in this equation. Then it's implemented as in the second equation, which is the sum of squares of the digits of the representation. Write a program to compute the sum squared digits function of an input positive number. For our input, the first line of input contains a single decimal integer, p, where 1 is less than or equal to p is less than or equal to 1000, which is the number of datasets that follow. Each dataset should be processed identically and independently. Each dataset consists of a single line of input. It contains the dataset number, k, followed by the base, b, where 3 is less than or equal to the base is less than or equal to 16 as a decimal integer, followed by the positive integer n also as a decimal integer, for which the sum squared digits function is to be computed with respect to the base b. N will fit in a 32-bit unsigned integer. The dataset number k starts at 1 and is incremented by 1 for each dataset. As for our output, for each dataset there is a single line of output. The single line of output consists of the dataset number k, followed by a single space, followed by the value of SSD, which takes in b and n as a decimal integer. Alright, so let's go to our example code. The first thing we do here is take in our required p number of inputs. In the second line, a list is created for all of our solutions just to keep track of them for right now. This is not mandatory, as it's just for readability purposes, and you can remove this line, replace what's in line 23 with a print statement, and remove everything after line 25. Everything else we do computationally is in the for loop beginning in line 4. The first thing we do here is to take in the numbers that we need. In lines 7 and 8, we cast the data from a string, which is what the input function gives us, into integers. We also make this list of bases that we'll use later on. After this, we need to find the largest exponent digit that can fit into our number. Lines 13 through 15 count x up from 0 until the base to the power of x is greater than the number that was given. In this next section, we looped from the maximum exponent all the way down to 0, counting backwards along the way, in order to follow the equation given in the problem description. There's 3 things we do here. The first thing we do is we make this temporary variable, that is our number, integer divided by our base to the power of I. This gives us the digit that we need to use for this cycle. The next thing we do is to add the digit squared into our bases list. And then the last thing we do is to subtract the value of this from our total number. This is repeated to get our sum squared digit. On line 23, we just format the input a little bit by putting in our iteration and the sum of the bases in here, and then print out all of our results over here. That's it for the code, so let's try out our sample test cases. Our one and only sample test case is 3, 1, 10, 1, 2, 3, 4, 2, 3, 9, 8, 7, 6, 5, and 3, 16, 9, 8, 7, 6, 5, 4, 3, 2, 1. And our expected return value is 130, 219, and 696. As our program functions correctly, that will be the end of this solution video.